Hello, and welcome to part 3 in our video series of dose ratios and monitor unit calculations. This is the final video in our series, so I would encourage you, if you haven't watched part 1 or part 2, to go back and watch those, as we will be applying the concepts and the dose ratio that we have learned in part 1 and part 2 here in part 3 to go over a sample calculation you might do in a clinical scenario. A quick overview of what we've talked about and what we've learned. We've talked about depth, field size, and distance correction factors, and the dose ratios that we used to make these corrections. We've also talked about then some other types of correction factors we use, such as off-axis factors, or any attenuation factor that we would use to account for external devices we attach to the machine, which may affect the beam during treatment. And if you'll remember our dose calculation formulation that we talked about at the end of part 2, so our general dose calculation formula looks something like this. It's just our dose times our calibrated output, our centigrade per monitor unit under calibration conditions, the number of monitor units delivered during the treatment, and then all of the output factors that we calculated and we need to use to convert from the calibration condition to the specific treatment condition under which we're trying to calculate dose. So now, let's say we wanted to calculate the number of monitor units that need to be delivered so that we can deliver the prescription dose D to the patient at the prescribed point in the patient. So in this case, we would use our dose calculation formalism, and we would solve for monitor units. So our monitor units are equal to our prescription dose divided by our output calibration factor times all of the dose ratios we need to use to convert from the calibration condition to our specific treatment condition. So you can see for SAD beams with an SAD calibration, our depth dose factor in this case is TMR. However, if we had, and we were treating a patient with an SSD setup, but we did our calibration in an SAD setup, then we would have to use an inverse square factor times our PDD to be able to calculate our MUs. Okay, we'll look at a clinical scenario here. In this case, a whole brain treatment. So the patient is prescribed 30 gray total dose, 300 centigrade per fraction, 10 fractions, 5 fractions per week. We're using a 6 MV X-ray beam with parallel opposed fields, and we're prescribing dose to isocenter. Our field shape is 20 by 18. The patient is set up isocentrically with a lateral separation of 16 cm. So I tried to highlight the pertinent stuff here for our calculation. We're doing 300 centigrade per fraction, right? 6 MV beam, parallel opposed right and left lateral fields. So we have 2 treatment fields. We're prescribed to isocenter with a 20 by 18 rectangular fields. Again, the patient is set up isocentrically. The dose calculation point is at midbrain, and we have a lateral separation of 16 cm. So that's a lot of information. So what I do, I always draw a picture. So please forgive my lack of artistic skills, but you get the idea of what we're trying to do here. So we draw our patient. We're set up to 100 centimeter SAD. We're using 20 by 18 rectangular fields. The lateral separation of the brain was 16 cm, and we're calculating dose to midbrain. So that means each beam penetrates 8 cm depth. So we want to calculate dose at 8 cm depth for each of our treatment fields. So how would we get started with our sample calculation here? Well, first, let's compute our equivalent square fields we're going to use as the field size in our lookup tables for our output factors. So we know we have rectangular fields that are 20 cm by 18 cm. So if you remember our equivalent square equation from part 1, we plug in our values, 2 times 20 times 18 divided by 20 plus 18. That gives us an equivalent square field size of about 19. So we'll look up in our calculations, in our tables for our calculations, we'll look up a 19 by 19 square field. Next, we look up our output factors and our TMRs. So we use a field size of 19 by 19 cm, and we know we're looking at a treatment depth of 8 cm from our setup. And then finally, once we look up all our factors, we will plug those into our equation. We know the treatment dose to be delivered, and then we can calculate the number of MUs we need to deliver this prescribed treatment. Let's look up our output factors that we need for this treatment. So we'll go to the output tables that are provided by the department, and we would look up, for instance, here our scatter factors. And we would say, okay, for a 19 by 19 cm field, so we have 15 by 15 and 20 by 20 in our table. So we would sort of interpolate between those two values to get 19.19. We might use, for instance, 1.025 and 1.019 for our two factors. And then we would go to our TMR table. Since we're set up and delivering isocentrically, and we will make the assumption that our calibration was done isocentrically. So again, we would go over here and we have 15 by 15 and 20 by 20 field sizes in our table. We scroll down to 8 cm depth where we're doing our calculation at for this treatment. And we have 0.855 and 0.863. So we would again interpolate between those. We would get our value. And we would plug those into our equation. So the number of monitor units would be 300 centigrade, which we want to deliver for our fraction, divided by 1 centigrade per monitor unit under calibration conditions. And then we apply our output factors to convert from calibration to our treatment condition. So we have our scatter and our collimator factor, 1.025 and 1.019, and our TMR, 0.86. We have no trays, we have no wedges, so we leave those factors as 1. And we calculate that the total MU to be delivered would be 337.5. So 338 MU to deliver our prescription dose for this patient. Now remember, we had 2 treatment beams, right? They're equally weighted, and we have an equal separation depth between them. So we can just divide our MUs in half and say our MU per treatment field in this case would be 169. And so that's basically it. That's how you would calculate the MUs to deliver a prescribed dose under this whole brain clinical scenario. So let's wrap up part 3 here. And this wraps up our 3-part series on dose ratios and monitor unit calculations. As always, if you have any questions, please leave me a comment. I'll do my best to answer it. If you want to see more videos, please leave a comment, suggest a topic. I'll do my best to make a video for you. And as we are obligated here on YouTube, please like our videos, subscribe to our channel. It lets us know you like what we're doing, and it helps encourage us to bring more content to you for learning different concepts within radiation oncology.